I hope you can see that this illustration represents that 1/3 plus 1/3 is equal to 2/3. And here's another illustration, 1/3 plus 1/4. But it's a little unclear what part of the circle those two pieces together represent. Clearly a little more than half the circle, but we want an exact answer. So we'll divide those circles both into 12 equal pieces, and now we have 4 12s plus 3 12s, and we can see that the two pieces together make 7 12s. So 1/3 plus 1/4 is equal to 7 12s. Here's another, and we'll try to do this without an illustration. 5 12s plus 7 tenths. For showing our work, we'll write these two fractions in a vertical manner as shown, and we'll apply the equal fractions property. We're going to multiply the 5 12ths, both numerator and denominator, by 5, and in the 7 tenths, both numerator and denominator by 6. And that's going to give us 25 60ths plus 42 60ths. And by the way, 60 is the lowest common multiple for 10 and 12. And then we get 67 60ths. The numerator is an integer, the denominator is an integer, so 67 60ths is a simple fraction in lowest terms. Let's do 5 6 take away 3/8. We write them vertically to show our work. The lowest common multiple between 6 and 8 is 24, so we need to multiply the 5 6 times 4 over 4, and the 3/8 times 3 over 3 to get 20 24ths. Take away 9 24ths, which of course is 11 24ths, and that's our answer to this problem. And here's 5 6 minus 3/8 yet again, only this time, instead of finding the lowest common multiple, we're just going to multiply 5 6 by 8 over 8 and 3/8 by 6 over 6. Now we get 40 48ths and 18 48ths because 48 is a common multiple of 6 and 8. It's just not the lowest common multiple. So our answer is 22 over 48, but we can still work with that. But if you don't use the lowest common multiple, your answer will be guaranteed not to be in lowest terms. So we divide both those numbers by 2, we get 11 24ths, the same answer we had the first time. We're looking once again at the simple fraction 67 60ths. A fraction in which the numerator is larger than the denominator is called an improper fraction. And you might guess then that a fraction in which the numerator is smaller than the denominator is called a proper fraction, such as the one shown here, 59 60ths. Now let's get back to 67 60ths. Some of you know that we often rewrite improper fractions as something called mixed numbers. And in order to do that, we divide the numerator, 67, by the denominator. And of course, 60 goes into 67 one time, and there's 7 left over, or 1 remainder 7. The improper fraction comes from this division problem. The 1 is our big number, the remainder is our numerator, and the previous denominator, 60, is still the denominator. The arrows show where all those numbers go in the mixed number. So 67 60ths is equal to 1 and 7 60ths. And a number written with a counting number next to a proper fraction is called a mixed number. Here's 28 fifths. We do 28 divided by 5, goes in 5 times. There's 3 left over, 5 remainder 3. One of the 5s is the big number, one of the 5s is the denominator, and the 3 is the numerator of the fraction part of our mixed number. So 28 fifths is equal to 5 and 3 fifths. And now we're going to add 5 and 3 fifths plus 1 and 7 60ths. Well, one of the ways to do this problem is to convert the mixed numbers to improper fractions. Of course, we already know what these are, but if we didn't, we multiply the denominator 5 times the big number, which in this case is also a 5, and add the top number. And that gives us the numerator of our mixed number, and the denominator stays the same. It's still 5. I like to say bottom times big plus top. And we do the same thing with 1 and 7 60th. Bottom, which is 60, times big, which is 1, plus 7, which makes 67. The denominator stays the same, 60. So now we have 28 fifths plus 67 60ths. And we're going to need a common denominator, but since 5 goes into 60, we can leave the 67/60ths alone. Multiply the 28/5 by 12 over 12, and that's going to give us 336/60ths plus 67/60ths, which is 403/60ths. And it turns out that 403 and 60 have a GCF of 1, so that is a simple fraction in lowest terms. It happens to be an improper fraction. If we wanted to convert it to a mixed number, we do our division problem. 60 into 403 is 6 times. Giving us 6 times 60 is 360. We subtract and we get that there's 43 left over, or 6 remainder, 43. So our mixed number is 6 and 43/60ths. Here's another way to do this problem. We write the numbers vertically, and then we just convert the fraction part of our mixed numbers to fractions with a common denominator, giving us 5 and 36/60ths and 1 and 7/60ths. We add 36 and 7. We get 43/60ths, and 5 and 1 is 6, so our final answer is 6 and 43/60ths. And of course, that's the same answer we got the first time. Now we're going to have a similar problem. Instead of 1 and 7/60ths, we now have 1 and 47/60ths. So we have 5 and 3/5 plus 1 and 47/60ths. We convert again, and now we have, on the top, we still have 5 and 36/60ths, but on the bottom we have 1 and 47/60ths. We add 36 and 47, and we get 83/60ths. Now that looks like a mixed number, but if you look again at the definition of mixed number, a mixed number is a counting number next to a proper fraction, and this is a counting number next to an improper fraction. But we can do this in our head. We know that 60/60ths is equal to one whole number, and then we know that 83 take away 60 is 23, so we could rewrite 83/60ths as 1 and 23/60ths. I won't write that down because we can do that mentally. 1 and 23/60ths plus 6 is 7 and 23/60ths, and we write that up on the top, and that's our final answer to the problem 5 and 3/5 plus 1 and 47/60ths. Here's a subtraction problem with mixed numbers. We write it vertically as shown. We're going to change just the fraction part of our mixed numbers. So now we have 9 and 25/30ths. And 3 and 28/30ths. But when we go to subtract 25/30ths, take away 28/30ths, it can't be done. So we have to do what I call borrowing. Some people call it regrouping. But we cross out the 9 and change it to an 8. So we've borrowed 1 from the 9. But instead of writing it as 1, we write it in another way, 30 over 30, because 30 over 30 equals 1. Now we take that 30 over 30 that we've just borrowed and we add it to the 25/30ths that are already there to give us 55/30ths. Now we can subtract 55/30ths, take away 28/30ths to get 27/30ths. And then we have 8 take away 3 to get 5. Only this time when we examine the 27/30ths, not in lowest terms, but that can be done mentally. 27/30ths is the same as 9/10, and our final answer is 5 and 9/10. This lesson looked at addition and subtraction of fractions, proper fractions, improper fractions, and mixed numbers.